Thank you, Sophie, who texted us a Twitter thread from Alex Weatherall. And I'm going to read the thread to you, and then we'll go to somebody on the line as well, called Milo, who has an understanding of how these algorithms work. So we can try and get to the bottom of it. So if you're a parent, do pay special attention now, because I'm going to explain to you what's been sent to me. Well, I'm going to read to you what's been sent to me, not pretend I can explain it, but hopefully Milo can, and can also tell us if what I read is correct or not. But Alex Weatherall on Twitter has said, I was going to wait till tomorrow, but I can't. The U grades, this is me just reading the tweet thread, the U grades and other large drops appear to be the result of a rounding issue when assigning ranked students to their grades. It'll be hard to explain via Twitter, but I'll try. Please bear with me as I use a simplified example. Imagine a cohort of 20 students. Each of those students, remember, brackets, they represent real people who have probably worked very hard alongside their teachers for 2 years. Never forget that, close brackets. Each student is nominally worth 5% of the grade distribution, however it falls. Now, the students, according to their teacher, have been assessed during this time, and they perhaps sat a mock or two and have done essays. So the teacher submits a grade and a rank for each pupil. The grade is a suggested grade for Ofqual, which is the Office for Qualifications that looks at this stuff. But the rank is a distinct order, and it ultimately will determine what grade each student will receive. The rank, keep in mind, is different to the grade. Ofqual clearly has some form of percentages, it says, need to work with the predicted grades that they get so that the grades aren't too far off from last year's averages. Now, I'm going to carry on reading. Alex Weatherall says, now coming up is the magic I will never know because I don't have all the data, but Ofqual have described it comprehensively. All those grades from those 20 imaginary students, along with all the others from all the cohorts for that subject, form a distribution of grades that Ofqual can prod and poke to see if it's a fair distribution. Ofqual decided it wasn't fair. Adjustments needed to be made. Fair enough, that's expected. So they use a combination of the subject history at that school and the prior attainment of the 2020 students to come up with a distribution of grades that the 20 students we imagined have to fit into. So let's give the examples from Alex Weatherall's tweet. It says, imagine these were the ranks that they had to fit into. That only 7% get A stars, only 15% should get A's, only 22% should get B's, and so on and so forth. And then he says the problem with this is that the 20 imaginary students have to fit into those percentages regardless of their predicted grades. Now, he's saying, notice I haven't told you the students' grades because it's now irrelevant. The rank is king, those percentages that they have to fit into. So say student number 1 gets an A star, every student is worth 5% because there's 20 of them. So student number 2 would take the number of A stars to 10%. But if the rank at Ofqual only allows that school to have 7% A stars, then even a second student in this imaginary example getting an A star would take that to 20%. Out of 20 students, each pupil is worth 5%. 2 pupils with A stars would take it to 20% of the total, getting A stars in that school. But the rank at Ofqual is saying, no. You can only have 7%. So now you have to shave a grade off just to fit into the percentages.
Yeah, there's more details to it, and it is correct. So basically what's happened there is there's a massive skew. So what's going on is it's not an algorithm problem. It's the people or the companies, whoever they are, that are trying to fit something in there. So you can have an individual like myself and my team where we take into consideration that these human beings, they've been late, this whole coronavirus kerfuffle. But if you have an algorithm that, the company has to meet the targets, well, they're not going to do something like that. So it has to fit a certain parameter.
And before you carry on, what's your background in this that helps you understand this?
So basically, I taught myself machine learning and AI for 3.5 years.
Oh, wow.
My CTO is a classically trained data scientist. I'm a front-end programmer. He's a back-end programmer. Yeah. And we've had a company now for 3 years. So another situation is we try to let the people know that algorithms don't think, Maajid. They're not sophisticated. They can't do what humans do at this moment in time.
Yeah.
A lot of people have this misconception because of the Terminator 2 scenario that these things are out there. It's not true. And even when they talk about an algorithm being biased, that's also not true, because an algorithm is only as good as the data scientist that train it.
So it's the human that was biased. that programmed
Right. Yeah. So what will happen when you have, I know you're going to talk about facial recognition.
Oh, we had to dump it for this hour. So next hour is on Belarus, but we will return to the subject, definitely.
Sure. So I'm using that as an example because it uses something convolutional neural networks, and that's basically pixelated, so 0 to 255. So if you have a data scientist that is getting data from pictures, and all of the pictures have fair skin or light skin, and they do not have enough representation of dark skin. So what will happen is when you have a camera somewhere or something that senses skin complexion, it wouldn't recognize the dark skin because the model wasn't trained with dark skin. That's not an algorithm being biased. That's just a data scientist not putting enough references to different pixelation of melanin people, or it doesn't have a greater data to go on, and that's just it. That's basically all.
And so with this particular algorithm, in terms of the A-level and GCSE results, explain how then, just again for people to understand, how does one student go from getting an A predicted and then being granted a U by the algorithm?
All right, okay, so very simply, let's just look at it. An algorithm does something. So you have information in and information out. You know where you are and you know where you want to go to. So what happens is you dump the information into the data. You have to clean it. You have to, put this column together, blah, blah, blah. And then what happens is the algorithm uses mathematical influences, whatever it is, to say, right, this is the outcome based upon what you want to get. Now, what's going on here is if you have 3 or 4 or 5 students that are predicted a grade, maybe they have, 3 A's, 4 B's and whatever. But what happens is if you don't have... if they don't have a variable like the coronavirus, like 6 months of no data, and then what you try to do is you try to go from 2 years ago to get another data set that's been, put together by another data scientist that doesn't know this set together and put together. What will happen is simply, if you now have 1 student or 2 students that have predicted AAAs and all of the other students that have predicted C's, that 2 students with AAA is going to skew the whole thing. So the distribution is going to be off kilter because it's just it's almost like if you have to make it easier, if you have 100 people that are earning, I don't know, 35,000 to 40,000 a year, and then you come and put a billionaire in there, it's going to skew the whole thing.
It's going to skew it, that's right.
It's just going to skew it, and that's it. So all of these universities, what have you, they don't have the technical know-how because all of these things are being offshore to other countries. That's another problem. They don't have the technical know-how. So when something like this happens, they're not quick enough to get to the information, go, what's just gone on? And you do have more sophisticated algorithms that actually tell you why this is this and this is that. It's not a simple, computer says no, but yet again, it takes a lot of money, it takes a lot of understanding, and it takes a lot of not sort of cooking the books and try to, pay cheap now and pay for it later on. And that's what we have,